People have always had the need to know what could be. Here, in this classic clip art image, we see a businessman consulting the services of a clairvoyant. What do you think the business stakeholders would think of this approach to predicting what could be? Then there was Paul the Octopus. Accurate predictions in the 2010 World Cup brought him worldwide attention as an animal oracle. But he doesn't offer predictive services to businesses. And so in this presentation, let's consider a scientific approach to predictive analytics that is used by many successful businesses today. Machine learning, according to Wikipedia, is described as a subfield of computer science and statistics that deals with the construction and study of systems that can learn from data rather than follow only explicitly programmed instructions. Let's see by example. I have a need to add two numbers together, and I recognize then the need to develop a function that takes two numbers as input, and I could easily solve this with a programming language today. Let's consider then a different question. The need to predict customer profitability, and the recognition that I require a function that would take inputs of customer demographics, like age, marital status, gender. And then I attempt to write a function using a programming language to output some prediction of profit. Well, at this stage, you're probably on the wrong path. Machine learning, given that it's provided some good quality representative data, could machine learn over this using algorithms to detect patterns, output a model, and this model could be used to predict customer profitability. The machine learning flow begins by defining a clear objective, like let's predict customer profit. It then involves a collection of data, typically good volumes of representative, clean, current, consistent, credible data. This data is often not in an optimal state or state of cleanliness ready for machine learning. So often we use data preparation to ensure the data is in the best possible shape to proceed with the training of models against this data. And the training of a model involves a selection of an algorithm, determining inputs, outputs, also tuning the algorithm according to its properties. And then we evaluate how well the model is fit for purpose, typically ensuring that it is accurate, reliable, and then we don't just train one model, we typically train multiple. So this is an iterative process of training, evaluating, ultimately arriving at a model that is best fit for purpose. At this stage, the model could be published and then managed to ensure that it remains available and it scales according to predictive requirements. At this stage, the published model is then available for integration into some application experience. There are several roles that are concerned with machine learning. The most common role associated with machine learning is that of the data scientist, a highly educated and skilled person that is educated to solve complex data problems, employing deep expertise in scientific disciplines like mathematics, statistics, or computer science. Data professionals can also work with machine learning. These skilled individuals can create and maintain data systems, data solutions, and also implement predictive modeling. Data professionals can include DBAs, database developers, even BI developers. And then there's the role of the software developer. As a skilled individual that designs and develops programming logic and user interfaces, they will typically be engaged to integrate machine learning in some way into an application. There are numerous challenges with machine learning. Strategic change, there are lots of buzzwords, new markets, high competition, and essentially machine learning can be expensive. It might have to work with challenges of isolated data, tool chaos, and complexity. Traditional approaches without machine learning might involve guessing, rules of thumb, trial and error, which ultimately may not be optimal, may not produce the best outcome for the business. So the consequences could be lost opportunities and expensive operative mistakes. Azure Machine Learning enables powerful cloud-based predictive analytics. Professionals, so not just data scientists, but data professionals, can easily build, deploy, and share advanced analytic solutions. Armed with nothing but a browser, professionals can log on to Azure and develop predictive models from anywhere and deploy new analytic models quickly. They can retain a practically unlimited number of files on Azure storage, and it connects seamlessly with other Azure data-related services, including Azure HD Insight for big data, Azure SQL Database, and virtual machines. There's also the ability to connect to SQL Server on-premises. How does it work? Well, in the Azure portal, the Azure Ops team can provision an Azure Machine Learning workspace. Then, using the browser-based ML Studio, data professionals can create experiments and can also train from different sources of data. Having produced an experiment that they choose to publish for predictive service, they can then publish to this machine learning API service, whereupon application developers can develop a range of applications, be them web apps, mobile apps, also involve Azure Stream Analytics, and output real-time results to Power BI dashboards. This allows business users to easily access results from anywhere and on any device. So it's one solution for machine learning. Faster towards solution, a mashup of powerful algorithms consisting of industry standard algorithms and those developed in-house by Microsoft, used by Xbox and Bing. The Azure model of elastic pay-as-you-go modeling with low operative costs, you pay for what you use. And as you need scale, the global scaling of solutions via a cloud API. This delivers quick and easy extensibility with cloud functions including Power BI, Hadoop with Azure HD Insight, and Azure Storage. Let's consider business scenarios, but first of all, a message for IT professionals. Machine learning is one of the most popular fields in the discipline of computer science, and it is also perhaps the most feared by developers. And the fear is probably due to the understanding that machine learning is a scientific field requiring deep mathematical expertise. But machine learning has two disciplines. There's machine learning and applied machine learning. IT professionals can apply machine learning for acquiring practical hands-on skills that get machine learning algorithms to work rather than the mathematical underpinnings of machine learning. They can then integrate predictive functionality into application experiences. Imagine what you could use machine learning for. Targeted advertising. So rather than display random ads based on the characteristics or behaviors of your online users, you can adapt advertising to their needs and requirements. Churn analysis to understand those customers of yours that are likely to leave you. It is less expensive to retain an existing customer than it is to find a new one. Churn analysis can help detect and therefore allow you to promote incentives for those customers to stay. Image detection and classification. Equipment monitoring. This ties in nicely with the Internet of Things, that equipment that is being monitored with sensors. This information can be used to predict real time when a piece of equipment requires maintenance or it has gone offline. Recommendation engines, forecasting to take historical time series to project into the future, spam filtering, fraud detection, anomaly detection, all good examples of business applications of machine learning. In summary, machine learning is a subfield of computer science and statistics that deals with the construction and study of systems that can learn from data. The key attributes for Azure Machine Learning include that it's fully managed. There is no need to purchase hardware or software. It is integrated with ML Studio. You simply drag, drop, connect, and configure to produce experiments and to also publish them. Best-in-class algorithms. Proven solutions from Xbox and Bing. R built in, the ability to use over 400 R packages or bring your own R or Python code. The ability to deploy in minutes and operationalize within a click. And lastly, the message for IT professionals that machine learning is now very much approachable to them. There are a host of resources, including the Azure Machine Learning website, documentation, a very comprehensive FAQ site, and also details about pricing. Note that the free tier does not even require an Azure subscription or a credit card to get started. There's also the Azure Machine Learning blog. There's the Past Data Science virtual chapter with a growing number of videos sharing experiences with Azure Machine Learning, in addition to several conference presentations that I've made that include also an end-to-end demonstration on putting together an Azure Machine Learning project.